Hey everyone, welcome back to the Deep Dive. Today, we're plunging into a truly fascinating and rapidly evolving world. U.S.-India space collaboration. This isn't just about rockets and satellites, It's really about the future of global innovation, economic power, even how we tackle huge challenges right here on Earth. Okay, let's unpack this.
Absolutely. And our mission here really is to cut through the noise. We want to pull out the most important insights from our sources for you, help you quickly grasp the history, the current dynamics, and the future implications of this really pivotal partnership. Think of it as your express lane, sort of, to being incredibly well-informed on a critical global frontier.
And for this deep dive, we're mainly drawing on Mandy Bry's expert perspective. It's called the U.S.-India Space Collaboration, a perspective from emerging frontiers just out in April 2025, really packed with insightful observations. Now, when you think about U.S.-India space collaboration, you might assume it's, pretty recent, a product of today's geopolitics. But what really surprised me digging into this was how deep the roots actually go. I mean, we're talking way back, 1962, the formation of Inkuspar, India launching its first sounding rockets from Thumba, with direct U.S. support. That's a pretty significant early investment, isn't it? What was the thinking then?
Exactly. And that early collaboration, it quickly grew into some groundbreaking projects. You had the Satellite Instructional Television Experiment Site that used NASA's ATS-6 satellite, really pioneering stuff, beaming educational content to remote Indian villages, using space for social good. And that, paved the way for India's own national satellite system, INSAT. Now, sure, India's non-alignment policy, maybe leaning towards the Soviet Union for a bit, caused a temporary pause in direct cooperation, but ties absolutely revived post-Cold War. You saw this kind of space renaissance for India around 2004, and that directly led to setting up the Civil Space Joint Working Group, the CSJWG, in 2005, to formally coordinate things.
So from those very early roots, it sounds like the partnership found new legs, really, after the Cold War. And now when you look at projects like Chandrayaan-1 or the really ambitious NISAR radar, that's the NASA ISRO synthetic aperture radar, and indeed joining the Artemis Accords, it feels like that early foundation is, finally paying off in some monumental ways. This isn't just project by project anymore, is it?
Not at all, no. It's now strategically embedded, part of a much broader framework. It was called the Initiative on Critical and Emerging Technologies, ICE. But what's interesting is, during Prime Minister Modi's U.S. visit, just this February 2025, they rebranded ICT. It's now Trust Transforming Relations, Utilizing Strategic Technologies. And this new framework, it significantly expands cooperation. It's beyond just space now. We're talking defense, AI, semiconductors, biotechnology. It's become a truly holistic alliance.
Right, and we're seeing concrete examples of that happening, like right now. 2 ISRO astronauts are currently training at NASA. That's for the first joint U.S.-India mission to the ISS. On Axiom 4, scheduled for this year, that's huge. And speaking of this year, the NISAR satellite launch is coming up. That's poised to have just a massive global impact, right?
Yeah.
Disaster management, climate change, monitoring, infrastructure. It's a game changer.
Definitely. And building on that momentum, there's also this proposed Space Innovation Bridge.
Right.
It's under the India-U.S. Defense Acceleration Ecosystem, IND-USX, and the aim there is to directly foster U.S.-India startup partnerships, specifically in satellite tech and space situational awareness, knowing what's up there. Plus, on the defense side, things are deepening too. India is participating in the U.S. Space Command's Global Sentinel exercise, and there are ongoing reviews of missile technology exports aiming to help commercial satellite launches. It really underscores how comprehensive this whole strategic relationship is becoming.
Okay, let's shift gears a bit. Let's talk about the economic dimension, because space isn't just exploration or defense these days. It's a massive, booming global market.
Oh, it absolutely is. The latest estimates put the global space economy at something like U.S. $570 billion. Staggering. And what's fascinating here is the dynamic. While the U.S. still has the biggest single share of the global space budget, its percentage has actually dropped. It was over 75% back in 2000. Now it's around 60% in 2023. Now look at India. Their space economy is currently valued around U.S. $8.4 billion. That's about 2% of the global market.
But India has this incredibly ambitious vision for growth, doesn't it?
Yeah.
They're aiming to scale their space economy to U.S. $44 billion by 2033, with U.S. $11 billion just in exports. I mean, if they pull that off, that would give them a 7 to 8% share of the global market. That's a phenomenal leap in just a decade.
It is. And, they're kind of uniquely positioned to make that leap. You look at ISRO's accomplishments, Chandrayaan-3, SpaceX achieved on a budget that's, 15 times smaller than NASA's, that's not just technical skill. It demonstrates India's key strategic advantage in space collaboration. They can deliver high-impact results with lean resources, makes them an indispensable partner for cost-effective deep space stuff. And the OECD's outlook for the space economy, it highlights exactly this need. Partnerships to tackle shared challenges keep space safe.
So with such ambitious growth targets, how do they navigate, well, the tricky waters of global trade? Especially with this looming threat, potentially, of tariffs on Indian imports.
Right. Well, India's taken some very clever strategic steps there, shielding its space sector. For example, the union budget for 2025-26, it's significantly cut customs duties on ground installations, satellite launches, even goods for manufacturing launch vehicles. That directly lowers their input costs, boosts manufacturing, helps their export competitiveness. Pawan Kumar Goenka, he's the chairman of InSpace, pointed this out. He said these tariff reductions give India's space industry a distinct competitive advantage in global sourcing, lets them stay resilient even if other sectors face retaliatory tariffs.
That sounds like a smart move, insulating the industry like that. But even with those measures, I mean, every supply chain has weak spots, doesn't it? What are the bigger economic vulnerabilities for this partnership that maybe still need tackling?
Absolutely, you're right. The space sector, it's like any highly interdependent ecosystem. It's still vulnerable to cascading impacts across the whole value chain, from raw materials right up to highly specialized radiation-hardened components. And escalating costs, like we saw maybe with the Mars mission or NISAR, they can threaten to delay projects. At the same time, these economic pressures, they risk hurting startup competitiveness, squeezing access to capital. Ultimately, it could slow down the pace of innovation, which raises that important question. How do they protect this vital partnership? There's a really strong, critical need for proactive diplomatic engagement, maybe exclusive exemptions, and just a willingness to readjust trade and tech frameworks to really shield this partnership from those indirect tariff shocks.
Now let's talk about AI, artificial intelligence.
Yeah.
Because its fusion with space tech is it's creating some incredible advancements. We're already seeing it, right? Mission planning, autonomous navigation, analyzing huge astronomical data sets, robotics, Earth observation.
Indeed. But there are still significant untapped opportunities for both countries, especially, I think, when it comes to energy solutions for those long-duration space missions. Power is still a massive design constraint for future AI-enabled satellites that will have advanced edge computing, built-in AI infrastructure, powerful GPUs, complex algorithms, all needing substantial energy.
And here's something that sounds almost like science fiction, but it's real. Imagine tiny batteries using the slow decay of radioactive materials, like tritium or nickel-63, generating power for decades. That's beta radiation they're exploring, a potential game changer where you just can't recharge. NASA, for instance, they're planning to use this breakthrough. Ultra-high energy density batteries for all sorts of future applications. Deep space probes, CubeSats.
Exactly, and this presents a really promising avenue for collaboration, co-developing and sharing this beta voltaic battery technology, specifically for AI-enabled deep space missions. I mean, these things offer volumetric energy density nearly 100 times greater than lithium-ion batteries if you look over a 20-year lifespan. It's a genuine game changer for those long, power-hungry missions.
Okay, but maybe the most, jaw-dropping application of AI in space is its role in enabling this really ambitious idea of space mining.
Yeah. Now, while ISRO's current focus is still very much lunar and Martian exploration, let's be clear, India, being a signatory to the Artemis Accords and with its growing AI ecosystem, is actually exceptionally well positioned to explore asteroid mining. Think about it. India has proven capability in cost-effective space tech. Look at SpaceX, ADIYL1, plus advancements in propulsion, material science, robotics. Combine that with a strong space research pool and this burgeoning AI talent base. It provides a very solid foundation for developing space mining capabilities. So, specific collaboration opportunities? Well, developing advanced AI algorithms using existing data, things like hyperspectral data, that chemical fingerprint of a surface, and telemetry data streamed from spacecraft. You could use that to build powerful predictive AI models for prospecting asteroids, figuring out which ones are valuable. Both countries can also explore intelligent mining solutions using resources found in situ, right though in space. Maybe even develop next-gen power sources like radioisotope thermoelectric generators for these operations.
Ultimately, as global interest in asteroid mining really heats up, driven by this race for rare minerals crucial for everything from our phones to green tech, there's a clear strategic incentive for both India and the U.S. to position themselves together bilaterally as key key players in this next frontier of AI-enabled space exploration.
Right. And if we connect this back to the bigger picture, the path of India-U.S. collaboration, it holds immense strategic and technological value, especially in today's global security landscape, and particularly in the Indo-Pacific, fostering this vibrant, resilient space ecosystem, one that drives innovation, deepens collaboration, builds a sustainable value chain. It's no longer just optional, is it? It feels absolutely imperative for our collective future.
Yeah. And maybe a final thought for you, our listener, to consider. As Space 2.0 evolves so rapidly with all this tech disruption and AI really emerging as a force multiplier, both India and the U.S., they really need to adopt what you might call an avant-garde approach. Bold, adaptive, truly future-ready. Because the near future, it demands more than just visionary statements, doesn't it? It calls for actionable strategies, agile execution, real partnerships, building an open, inclusive Indo-Pacific economy. The legacy of this collaboration, I think, will really be defined by a collective AI vision for advancing in space. Thank you for joining us on this deep dive, and we definitely encourage you to keep exploring these fascinating topics.